Alright then, hello guys. Today we're gonna come back with another video, and this one's gonna be a gas puzzle one. So I'm gonna make another video like this. It's gonna be a Solidity based where we're just gonna talk about gas optimization. And this one's gonna be because recently there's been a huge wave of gas optimization problems that have been getting very popular in Twitter, and this is one created by RareSkill. This one is going to be optimize distribute, in which we're going to optimize this smart contract to reach a certain amount of gas use or gas efficiency. Because in Ethereum, as we all know, or as many of you guys don't know, some of the gas fees on Ethereum could be really high, and there's multiple ways how you could optimize the gas fees, whether it be just changing certain things when you code, or just doing certain things. So here's a link of all the current repository challenges that they have currently on their GitHub from RareSkill. It has multiple gas puzzles, and people have made write-ups on these online. And this particular challenge that I'm gonna do right now is gonna call distribute, like I said before. And someone already made a write-up about this, so I'm just gonna go off their write-up. If I remember correctly, the person who made this write-up, his name is Cigar, I think, or Siger, I think. Yes, Siger. He's a very popular, or like a well-known dev. I'll link the Twitter thread in which I got the information from. And like before, I guess, again, I'm not a pro when it comes to this kind of stuff. I'm just following his Twitter thread and trying my best, just like reiterating it back to myself. So let's start. So let's see. First things first, at first glance, we see that there are there's two variables, create time and contributors. One of the very first things that I guess Siger mentions is that one way to save, I guess, one way for gas efficiency is just changing public variables into immutable variables, or just making storage based variables into immutable, because immutable saves gas. Because if I remember correctly, it's deployed in bytecode. So we're going to change the create time to an immutable variable, and we're going to make it a private. And one thing that we could do on this end is just by adding, since we know the end time is the block timestamp plus 1 week, we could just create an end time variable which will be called immutable, and just set end time in the require statement. And also one thing we could change is change the contributors, because since we know there's always going to be 4 addresses, and since we already know that, we could just make 4 separate variables to store each immutable address. So in this case, I'm gonna make address payable immutable to every contributor. So I'll call this one add 1. Then I'll just copy and paste the exact same code 4 times. And then in contributors, I'll just have to make them payable 4 times. So it'll be 0, 1, 2, 3, 4, and set them back to add 1, add 2, add 3, and add 4. And the very next thing that we could do is change is the transfer variable. So there's multiple ways how you could transfer stuff in Solidity. One of the most common ways is by using the transfer function, but another way to transfer stuff in Ethereum is using send. And I think Siger put a link down below on like the difference between using transfer and send. But with send, I've heard that one's like very I guess not as safe as transfer. So in our case, we're going to be using send, which saves us, I think, approximately around 100 gas. And I guess the very last thing that we could do at the very end to optimize this is by using a self-destruct, because with self-destruct, it saves us a lot more gas than the current one. So in the code below, I'm just gonna add a self-destruct statement at the end. And so let's see. I'm gonna do a self-destruct and send, because self-destruct just sends the remaining ether. Sends the remaining ether to contributors, to the very last contributor, which is just gonna be everything. So that's what we use that one. Now if you run this code, oh, it looks like I got an error. I wonder what error this is. I'll be back with this error. Oh, okay, I'm back. Well, it looks like the error was just like, I guess I was calling address by self-destruct, but you could just run self-destruct and put the name of the address, which kind of makes sense. And then we're gonna run the npx hard hat test case again. So it successfully compiled and we got warning errors, because like I said, I think I guess send is more like send is not like the ideal way of sending stuff, of sending, I guess, ether, but it's not like the ideal way of sending ether. I think transfer is preferably more safer. And we're gonna see our result right now. We passed our current gas goal. And just out of curiosity, let's just see what add 4.send, see how much gas the gas difference is, because right now we have like 57k. Yeah, we use around 57,000. Now if you were to run this and with add 4.send, let's see if we meet the goal. And it looks like one failing. So what's a fail? So 61k. So it saves us around like 4k of gas. So I guess that's a very fun fact to learn how with Solidity. Self-destruct saves gas, but that's like self-destruct, like I said before, is usually used to drain all the money from Ethereum contract to another contract. It's just a way of like saying self-destruct is like it's just like a last. It drains the contract, the current contract, and sends all the ether to a different address or to a different contract or a different wallet. So I guess that's a very fun thing to learn. Fun fact, I think it was called suicide before, but they changed the name. So that's pretty interesting. Now, I guess this is it. I'll link down below the Twitter thread of which I got this from, but this is pretty interesting to learn. Probably next video is going to be another reversing video in which I could do for next time. Peace.